And I'm going to share my screen. So decided we'll start with swappable modules, I guess. So there's this issue in the Substrate Developers Hub issue queue, which is where we write all the documentation. And we talked about this briefly last week. And this is where I'm like tracking progress on documenting swappable modules. And I've made some really good progress at this thing that's linked here, which I called Marketplace. And so maybe I'll do a quick tour of that, but then what I'm hoping to do is try to code up another one today that's small enough that maybe we can get through it. So here's Marketplace. So in my node runtime folder, I have the regular lib.rs, and then I have a bunch of other stuff in here. One of them is called reputation trait. So basically the structure is this. The main module is Marketplace, and it's like a place where you can post things for sale and then your peers can buy them. And it takes some reputation system because you want to be able to rate each other, like, oh, this seller, you know, was bad at communicating and slow at shipping and sent me a broken thing, or like, hey, this seller was great, I'd recommend them, or leave feedback for each other. So the idea is we want to make Marketplace loosely coupled to some notion of reputation system. We're going to do that through this reputation trait, which is this shortest of the files. And then there's two different implementations of the feedback system itself, or the reputation system itself. And right now I only wrote one of them, which is simple feedback, but the next one will go beta. So if we start in Marketplace, I'll just show you the couple methods that are on here first. So in declare module, I guess, is where we can start looking. Functions start here. So actually, maybe I'll ask you, like, have you dug deep enough into Substrate that you feel like you know where we are, or should I give a little more?
I know where we are right now. I wasn't sure about the previous file that you showed where you were implementing your own traits because you know, the examples that I've worked with so far were pretty straightforward in that you didn't customize the behaviors that much.
Okay, cool. Okay, great. So this is the one, this is the one you're saying you didn't recognize yet, right?
Yep.
Yeah, cool. So this file is actually sort of like the central point of this tutorial that I'm working on. So it makes sense that you haven't seen this one before. And I wrote this one entirely from scratch. And basically the one important thing in here is this trait. And so I'm saying, like, I'm going to make this trait called reputation, and different runtime modules can be a reputation system. And if they want to be a reputation system, then they have to implement this trait, which means they have to give me some notion of, like, how are we going to score each other? So, like, I'm just using integers, like someone with good reputation has a high positive number, neutral is 0, and like if you've ripped people off, then your score will go negative. Feedback is like what kinds of feedback you can give. So like the simple one I'm using now is just, I ripped this off from eBay, positive, neutral, or negative feedback. You know, you could think of other things like give an integer or just something like that. And then there's two methods that you can have. This is the like most important one, where a rater can rate a ratee. So like, you know, I, Joshy, am rating Hugh and feedback positive so far, or whatever. And then your score goes up a little bit. And then this is just a simple getter method. So you can see what someone's reputation is. And so since it's just the trait, there's no like bodies of these methods here. But when we go and define simple feedback and beta feedback, which are two different reputation systems, then we'll make sure that we give them all four of these things. So, okay, so back to maybe a more familiar place. In Marketplace, you can post a listing. You can cancel a listing. You can buy someone else's listing. And finally, then you can review someone. And the logic is such that you can only review someone once you've engaged in the transaction with them. So I can't just like review anyone I want. I have to have bought something from them or sold something to them, and then I can give them a review. And so like, you know, we could learn a lot of stuff about runtime development even looking through this one, but the part that's relevant to these like loosely coupled modules is down here. So after I say call into the reputation system. So basically all the logic up here, like we figured out someone just called review. So like who's the buyer, who's the seller, make sure that they're actually allowed to do some reviewing and everything. And then we delegate with this long line. So we first bring in like the reputation system, and we say, you know, treat it as an instance of that trait we just looked at, and then call its rate method. And so this is where one module, the marketplace, gets to call into another module, which in this case is simple feedback.
Okay, this is cool.
Yeah.
Yeah, no, I mean, one of the things about working with Substrate is that I felt like I was learning a new language that was different from Rust. I stopped I mean, of course, a lot of the syntax was the same, but anything else that you would know about building your own Rust solution was something that was sort of set aside.
Yeah, totally. And it was weird for me too, because my learning experience, like the thing that finally gave me that kick to learn Rust, like I said, I had wanted to for a while, but like the thing that finally was like, now is the time, is that I wanted to start learning Substrate. And so I kind of learned them together. And for a little while, I like didn't know exactly what was Substrate specific and what was like general purpose Rust stuff.
Yeah.
Okay, yeah, great. So so we see like two modules being coupled here, and I had said earlier that we're using like this loosely coupled module system, and what I mean by that is, although we're calling into simple feedback, we didn't write simple feedback in here anywhere. It's abstracted away by that reputation system trait. And the way that I made that happen is up here in our own modules trait. Let's see, where is that? Right here. So still in marketplace, in our own modules trait, I gave it a couple of requirements. And so this is, you can see the comment says configuration trait. So basically we're saying like, hey, if you want to use this marketplace module in your blockchain runtime, then you have to give it a couple things. You have to give it, first of all, a reputation system that it can delegate the reputation tracking to. And then second of all, this one's pretty standard and not specific to what we're doing now. But if it's going to issue. So, okay, great. So that's where we say that this marketplace thing depends on some reputation system. And then to see how we gave it one, we can go up here to librs and yeah, that's the right file. Oh, I forgot how big of a file this is. I want to do construct runtime. Okay, cool. So so you can see we gave it marketplace and we gave it simple feedback. So that's great. And then where we implement the trait.
What editor are you using? Oh, this is Atom?
Yeah, this is Atom. Yeah. There we go. Okay. So we have to implement the trait for every one of those modules that we gave. And so here I said reputation system equals simple feedback. And so that's where we couple them together, where we say like, okay, marketplace, use this specific feedback system. What editor do you use for Rust?
VS Code.
Yeah, I've seen a lot of people using VS Code. There's some pretty nice extensions, right?
Yeah, I mean, it was derived from Atom, so I don't know at what point they started having different features or whatever. But I somehow just got stuck with VS Code.
Yeah.
At the moment, yeah.
I didn't know it was derived from Atom. That's cool.
Yeah, it was forked from it or something like that, and then they just started adding features to it.
Yeah, nice. Okay, so then the final piece of the pie here is simple feedback. And the place where we declare like, okay, simple feedback is going to satisfy this reputation trait is where we implement that trait. And I did that right here. So we're going to impl reputation. Oh, and the reputation system needs a notion of account ID because we have to be able to somehow say like, whose reputation are we talking about? So when I'm implementing it, I have to give it some notion of account ID. And we're implementing it for this module, this simple feedback that we're writing. And then in here, that's where I implemented the required store feedback, the rate method, and the reputation method. So And then, so I didn't do this yet, but over here in beta feedback, I'll do the same thing. I'll implement the same score, rate, verification, and feedback. Okay, so my thought was maybe we can just go ahead and code one of these up today. And so I just barely started one called state changer. I haven't really done very much yet.
Could you paste your GitHub link in the chat?
Yeah, no problem. Oh, in fact, oh no, I don't have it open yet. For the marketplace that we just looked at?
Yep.
Yeah, totally. Okay, there you
go. Cool, thanks.
Yeah. And my intention with this is that, I'm pretty close to done. I just have to implement beta feedback and write some tests. And then I want to do like a video walkthrough, like a more detailed and formal version of what we just did. And then hopefully write a tutorial out of it so that it'll be available like in those formats. Okay, so was my idea. I wanted to do like a simple, basically like a more stripped down version of that, because I had to spend time like writing all the marketplace implementation and stuff that's not so relevant. So I was thinking maybe the trait that we would implement would just be called like sequence generator. And it only has a single method called next item. And then we could just do some simple sequences like the integers 1, 2, 3, 4, and then maybe like the evens or the squares or something like that, and see if we could put that together in the hour that we have here.
Okay.
And then we have marketplace to use as a guide for when we need it. So I wrote the trait, and I don't know I think I made sure this compiles. Just double check. Not that there's very much there yet. So then I thought a next good step would be to actually write one of the implementations. So we can just use this template module, and we can rename it to be called like integers, I guess. And then we can just start typing over this basically. Maybe our single storage value will be called like current integer. We can call it current, and it'll just store raw U32. And then we have to implement a function that was called, next item. And it'll only take the person who's calling it. And we don't even need to ensure that it was signed. We don't need to ensure anything. So then we'll just go back to our storage. Let's see, I called that current integer mutate. I always forget the syntax for how to use mutate like that, so I'm just going to copy it. There we go. Okay, cool. So I guess we just give it like one of these closures, and then it must be like a mutable reference, and so we'll just go ahead and mutate it. And then we'll deposit an event, and we can call, oh no, so my idea is that like this thing we're building now will be like dead simple, and it doesn't have any events or anything, and then the bigger picture thing that will depend on this, so like the equivalent of the marketplace depending on a feedback system, that will like wrap it in events, and maybe have some other methods like to skip the next item in the sequence or something. So that means we don't need decal event there, and it also means we don't need events there. And it means we don't need to do this. Okay, cool. And then one really important thing is we have to actually tell it that we want this thing to be one of these sequence generators. So we have to impl, what was that called? Sequence generator. For module. I wonder if I can write it like that. So this, sometimes I trip up on some of this stuff about like knowing where I need T to go and stuff. But Hugh, do you have any intuition about that?
I don't where the T goes?
Yeah, or whether the T goes.
Mm-hmm. I don't think you can do that because it doesn't know what T is in this context, right?
Yeah.
Or unless you pass T.
Oh, it would have to be, it might be, well, let's just see if the compiler helps us. That sounds like Sean, right?
Yeah.
Hey, welcome to the call. I didn't hear you join.
Oh, guys, quick question as well.
Oh, Jeremy too. So hey, how's it going?
Oh, everyone's here.
Yeah, awesome.
So can you help describe like T? Because I'm just still like getting into to like learning the syntax. So is that like a special meaning behind it, or is it just?
I think the right place to start on that, because since you said you're just getting into it, is probably right here. And so I'm writing a module called, well, I'm calling it integers right now, and it's basically a module that's going to have one storage value, and we're going to iterate through the integers. And every module, every time you write a runtime module, it has its own, it has a trait, and we have the convention that it's named trait. And as the comment says here, it's basically like the module's configuration trait. So every module has one. If you want to put it into your runtime, you have to implement that trait. And then, like in most of these places, we, like here, for example, we have T in scope, so we can use it. So like,
oh, gotcha.
So like, here's a good example. So once we're like declaring our module, we have this trait that implements all of the all of the other modules traits, and so we can use it. And so like here, we're saying like, I want to take the current integer storage, which needs this parameter T, the trait that we're working on.
Okay. Yeah, I posted in chat something that might work. I mean, if you want that to.
Let's see here.
It looks something like the.
Yeah, that's the same way I did it on the marketplace. I guess what I was wondering is whether we need that to be, whether we need it, or if I can do it like the dead simple way I have here without that stuff. So let's see. Let's let the compiler tell us. So in order to make it a sequence generator, we just have to give it. Oh, wait a second. Oh yeah. So here's the deal. Okay. When I'm going to implement this thing, I need to put that method next item in here as well, I guess. Oh, that's interesting. So how do they do that in marketplace? So here's what I'm struggling with right now. Over here in the simple feedback one, I put the function right in here where I was implementing, my reputation trait, which is like the equivalent of the sequence generator trait. But what I'm curious about is if I also wanted this to be dispatchable, like if I also wanted anyone to be able to call rate publicly, because now I don't know if I want to put it in like this implementation or in here in decal module. Anybody have thoughts about that?
End of the day, you can put it in the implementation and then just have a forwarder. So your declare module will just have a function which just calls that function. So
yeah, like wraps around it.
Yeah, and that's actually pretty good practice in general, because then you don't have to expose your dispatchable functions as public. You just expose the internal functions as public, and then other modules can call those internal functions.
Yeah. Okay, cool. So let's go ahead and do that. And for now, I don't think I even need to put the forwarder. We'll just see. Oh, and so now since I'm using T here, now I definitely do need it to, yeah, what was that? T trait for module T. Okay, cool. Let's see how close we are. Oh, well, actually, I need to first, if I just compile it now, I haven't told it to use integers yet, I guess. Let's just see what we get. Oh, sure, I renamed the template. So instead of template here, I now called it integers. All right. We got to. Oh, these are, I think some of these might just be warnings that turned into errors. So line 18, fix that. The next one was expected one of colon or at, found a right paren. Oh yeah, so I need to give it a type annotation here, I guess. So I know.
You get rid of origin here, right?
Yeah, I
It's
wonder.
no longer a dispatchable function.
Oh yeah, that's right. So that'll go in the dispatchable wrapper. Yeah.
Yeah.
We make it dispatchable, right? Yeah. So I want to share the thought that I had, even though it is irrelevant for that reason. When I was doing the marketplace one, I had to give a notion of account ID into the trait that I was doing here. And it made perfect sense in this case because we're saying like, okay, whose reputation are we talking about? We basically want a mapping from account IDs to what their current reputation is. And I was, in my thought of like, I wonder how much of copy and paste it'll be. I was thinking like, oh, this is something that should be different. I shouldn't have to give a notion of account ID to our new trait, which is just for generating a sequence because there's, it's not like we have an item per account ID or something. I'm glad that we didn't have to do that. That met my intuition.
Yeah, you can also probably get rid of the result in OK stuff because that's pretty specific to dispatchable functions.
Well, okay, it's got to return something though. I guess. Oh, well, no, I guess it doesn't have to return something.
Nope.
And then, yeah, and then when we put one in here, that could have result too. Well, okay, it doesn't have to return something, but we still want to know whether it succeeded or not, right? So
but it can't. This one, your function can't fail, right? There's nothing in the code so far that can fail.
Yeah. Okay, that's true. That's a great point. Whoops. Re-add. Okay, cool. So let's see how we're doing now. All right, impl template tray. Oh, sure. So more template stuff. I think that was 194.
And there'll be one more in this file under the construct runtime.
Yeah. So we're going to enable integers trait for runtime, and it didn't have event there.
And one more in construct runtime.
Yeah. Let's go ahead and call that integers. Integers module. We don't have any dispatchable calls yet.
You still need a call function though, because you're using declare module.
Oh, really?
I
thought that's
actually, I don't think it'll error either way. But I think if you add call, it won't cause a problem. That's my guess.
All right, well, let's see what happens. Note to self is call necessary when dispatchable calls.
You can definitely remove it, and it would work. I can tell you that.
Okay, nice. Oh, well, maybe this is the question then. Is call allowable?
Yeah.
Yeah. Okay, cool. Whoops. Sequence generate T not found in this scope. Okay, so that's in the actual integers module. And I guess the deal is we didn't actually ever tell it where that trait comes from. So guess we'll have to use crate sequence. Let's see if we can figure out how to get these relative paths right on the first try. So I brought it into lib.rs already right before the call started, right here. So, and then I used sequence generator, but I think I still need to do this. And probably spell it right. Okay. So now we're, oh, I didn't go
the impl says sequence generate as opposed to generator. Is that?
Oh, yeah. Oh, yeah, thank you. What did I call it? Generator, okay. Yeah. All right, let's compile. And so now we have cannot find t in this scope on 24 in integers. Oh, that's because this part goes here. And that's a consequence. And then, okay, I'm gonna try to recompile. Function next, expected result. Oh, that's because we took result out from the implementation, but not from the trait.
You lost a bracket.
Oh, thanks. Yeah, it's funny when you're in a group chat like this, you get this like new level of checking. You know, normally you have like your runtime checks and your static checks, and then there's even the like pre-compile checks of like, wait, the other people noticed that didn't make sense.
The original formal verification.
Okay, hey, this looks good. So we got past compiling our specific module, so I think we're going to be good to go. So I'm going to actually go back to writing code while that finishes up. And, oh, we actually did write that already, and we gave it storage. Okay, oh, cool. So this, this might be pretty much ready to go. We just won't be able to test it unless we put that dispatchable call in here. So let's just do it.
I don't know how far you are if you're going to touch on this later, but I would recommend doing something with the mutate because it will overflow at some point. So if your intention is for it to overflow, that's fine. But in general, I would like recommend doing something like saturating add or even just like overflowing add or something like that.
Yeah. So right. So is there a more like explicit way to communicate below the intended
You can call it other stuff.
Oh, cool. That sounds great. Yeah. Okay. Thanks. So let's just say like I'm going to call this one external next item. And so now we do need an origin. Someone has to call this, and it'll return a result. And so, like, basically the reason I'm putting the dispatching callback is so we can play with it, right? Because, like, if the code compiles, that's great, but we kind of want to make sure our integer goes up. And then another good thing that we could and should do is write tests. We'll stick with the funnest parts in the limited time here, though. So I guess we just want to ensure signed origin. And then we'll go ahead and call next item. And I think we might have to do it something like this. Self next item. And we'll go ahead and return OK. Oh, I guess we're still compiling the binary from last time. I'm just going to start over. Oh, and I also just remembered, I'll mention this now because it's something that I've been going back and forth a couple times. So we're working on v1.0 right now, and that's because I started with Substrate node new. And this is a pretty good place to be building. But in v1.0, there's this two-step build process where you do the WASM first, and then on the master, then that's all combined into cargo build. So you have to remember which one you're on and know whether you have to do that two-phase build. Oh, wow. Did that really build already?
Yeah, when you're doing runtime development, I just recommend just building the WASM because then you don't have to rebuild all the other parts and it's much faster in general.
Yeah. Yeah, that was great. Okay, cool. So, oh, we have to build it once though, so that we have to at least not have something that I killed with Control C so that we can run this thing. And then in the meantime, I have the Polkadot.js apps UI over here. I'll get it ready in my browser. Okay, ready for local node. Cool.
By the way, the function was wrapping add. So if you do like x dot wrapping add y, it'll always return a value.
Okay, nice.
Yeah.
So I'm not going to do it in the middle of compiling though.
Yeah, no problem.
It's like, so and I bring it in from storage value, or it's just there?
No, wrapping add is just always available.
Okay, oh, great.
I think in this situation, if I know correctly, it would wrap anyway because Rust defaults to wrapping when you build in release mode for overflowing stuff. Mm-hmm. So it technically doesn't matter, but it's, I guess, just like, for more explicitness.
Yeah, it's like really nicely self-documenting if it says like wrapping add as opposed to what it says now, which like if you ignore this comment is basically like this could be a bug and I haven't communicated my intention.
Yeah.
State changer. Well, we did introductions at the beginning, but since some new people have jumped in, Jeremy, have you introduced yourself on here, or David?
No, I don't think I have yet. I totally can. Give me a second.
Yeah, go ahead and do you want to introduce yourself, Jeremy?
Oh yeah, sure. Hey everyone, so my name is Jeremy. I do developer education with Pocket. I just like to kind of dabble around different things, and yep, here to support Dashi and learn some more about Substrate and the protocol.
Nice. David, do you want to tell us about yourself while we compile? And if you don't want to, or if you can't, that's okay. Welcome anyway.
Just curious question as well. Oh, sorry to totally cut you off.
Yeah.
But how long does it, does the average time does it take to compile?
Well, you're seeing it kind of, that WASM went a ton faster, right? And like one important thing is that you get the incremental build every time. So this time it started at like 506 out of 508 targets, I think, because most of the code didn't change. But yeah, they are a little bit long sometimes. I think, I don't know if this is true, but I think it's true, and it's a hypothesis at least. When you build the native code, it depends on the output of the WASM build. Like I think it needs to hash.
Yeah, that's true.
Yeah, so it seems like it takes a lot longer to do this build of the last target than I ever would expect. And I wonder if it's because like the WASM changed, so something more like advanced or more computationally intensive happens in that second phase of the build.
I just think the STD pathway, like when you're compiling the node with STD, it compiles like more things. Like it has to take care of all the things that actually need to run your node, right?
Yeah, right. But like even if we do this again, like if I make some small change just to my WASM code and then I run that again, it's going to take roughly that long again. You know, like it doesn't get to reuse whatever some of those artifacts are for some reason.
Yeah, I think it can only reuse at the crate level. So if anything about your crate changes, then it has to recompile the entire crate. It can't, like, it's not like it only recompiles one file.
Okay, I see. Okay, cool. So this thing's running. That's a good sign. And they're connected. And, oh, wow, there's a lot more stuff, a lot more tabs here than I was expecting. Did I run the right thing? Oh, yeah, I did. I ran state changer. That's what we just built.
Those other, maybe refresh the page. Those other tabs should only appear if it's in your node.
Yeah, that's what I was thinking. That's why I was surprised to see them. Those were in a node that I was running earlier. Oh, wow, that's interesting. Okay, cool. So we have integers here as a module, and we have external next item. So that's the one we had called. Before I call it, though, let's look at change state. Integers. And current integer is the only thing we can get. Oh, why did that?
It's known bug, known bug.
Oh, I didn't know that. Okay. Wasn't known to me. Okay, it's 0. Great. That's what we wanted. Back on extrinsics, we'll call integers external next item. And I'm calling it as Alice, not that that matters, because all we did was make sure that it was signed by someone, not that it had to be a particular person. And when we get a new block, oh, we just got one. So we can go back to change state and integers, and we'll look up current integer. Hooray, it's 1. And maybe we won't try it enough time to demonstrate that it overflows correctly, but I did bet it does. So, okay, that's great. So now I think what I want to do is add the module that's going to call this one, that's going to like wrap this one, and then we can do the swappable part with a second implementation. So duplicate, and we'll just call this one like wrapper. So, oh, I did not mean to duplicate that file though. Sorry about that. I meant to duplicate this module because all modules look fairly similar. Okay, cool. So the wrapper is not going to be a sequence generator. It's instead going to depend on a sequence generator. So that means we need to give it this type seqgen has type sequence generator. And it is going to have an event. It's basically going to emit an event every time we generate the next item. And I need to bring this in again, that sequence generator. Oh, I did already. Oh yeah, because I copied the other file, that's why. Okay, great. And then in decal module, we'll just have, it's gonna be kind of similar, I guess. Just so we can tell them apart, I'll call it wrapped next item. And okay, cool. So here's the part where we get to defer to the thing that we depended on. So the comment here is, I guess, like defer this call to the required here. So to do, I'll leave that undone for just a second so that I don't forget that the next thing we want to do is actually emit an event. And I'm going to just copy that syntax too. Self-depositive event. And we'll just call it like increment, or incremented only makes sense for integers, but like next state selected. In decal event, oh, I removed the part about decal event, so I'll copy that too. So we just have to declare this event that's called next state selected. Okay. That seems...
You want to maybe emit the item that got selected, just like a U32?
Oh, sure. Yeah, that's a good idea. Oh, well, yeah, so far it's always going to be a U32, I guess. But that is not going to be known to this module because that's not required by the trait. So we could be like iterating over like, or just circling around some items in an enum or something, or byte arrays. Like I think we could do it.
So it's going to be super generic then. Okay.
Yeah, so far it's super generic. It might be fun to sort of make it more explicit that it like requires some notion of, you know, like a stored type or something. But I think with the time left, maybe we won't do that right now. So, okay, so the last thing we needed to do then was figure out how to actually defer this call. And this was something that I got stuck on and had to ask the core developers for help with. This, if you're a good Rust station or good Rust programmer, this might not trip you up, but for me it did. And it looks like this right here. Okay, so here's like the proper way to, or like, I don't know about proper actually, but there's probably a way that I could like make a type alias and make this cleaner, but it gets everything to be what we need it to be. So we first have to refer to, like in this case, the reputation system that comes from our configuration trait. So that's why we do T as trait, and then whatever reputation system we were given. And then we have to say, like, you know, refer to the trait that it conforms to. The reputation system we were given conforms to this reputation trait. And then finally, we can call a method. So it's going to look something like this. T as trait is going to be the same, but I didn't call it reputation system this time. I called it sequence generator. And we have to make it look like the proper trait, so I called that sequence generator.
Yeah, for those of you who are familiar with the balances module, we do this almost anytime we use the balances module, where we create a type called balance of, and that allows us to generically kind of use different balances modules if we need to, and also access its functions and stuff.
Yeah, that's probably worth showing. Try to help me remember to do that after.
Yeah, I'll post a link in the chat.
Oh, great. So this part I'm going to remove this time. And the reason is the reputation system trait was required some notion of account ID, so we had to put that parameter in there. Sequence generator doesn't take any type parameters. So it actually looks a little bit simpler in this case. And then the function was called next item. Whoops. That looks probably good. Yeah. All right, let's try to compile that.
Stray close bracket in there, right after.
Oh, you're right, this one. No, wait, where are you talking?
Oh. Okay, no, never mind. It's part of the wrapper. Okay.
Yeah, sometimes they kind of don't, they're hard to trace, right? Is this the one you were thinking of?
Yeah.
Yeah. And it matches all the way. Okay, scripts build. Yeah, oh, that was great. That was really fast. Okay, so then target release, state changer. Oh yeah, and here's another good thing to always remember to do is purge your chain before you run it with a new runtime. It just clears out the old blocks from last time when things look different. I guess I will say one like minor pain point on iterating on runtimes is that it sometimes takes a little while for the UI to load again. Well, all right, let's see what's happening. Oh, there we go, right as I gave up. All right, it took 5 blocks. So this time in extrinsics, we see integers still, Oh, you know what we never remembered to do, guys? We never put wrapper into our actual runtime. We wrote the module, but we never wired it into the runtime. So that happens in librs, and it'll look pretty similar. It's pretty similar. Mod wrapper. Then we'll implement its type, or implement its trait. Simple wrapper trait for runtime. And it required, I think I called it seekgen. Yeah, seekgen and event. Equals integers. So this is the part where we do the like loose coupling, right? In wrapper, we said we need some notion of a sequence generator. Oh, sorry, knocked the mic. And then in the integers thing, we said, okay, I am some notion of a sequence generator. And this is the part where we glue them together. And then we also need event. And then we need to put it in construct runtime.
Yeah, notice that the integers is a capital I. So this integers type or object he's referencing is what he defined in the construct runtime.
Yeah, this one is this one. Wrapper, and so then we'll call this one wrapper. And this one definitely is a module, and it does have dispatchable calls, and it doesn't have any storage of its own, because the storage is delegated to the generator itself, but this one does have events. I think that's it. Failed to resolve use of undeclared type or module sequence generator, and this happened in wrapper.rs on 44. Oh, so I probably had to do like mod sequence generator, I guess, in the wrapper. I thought I did that.
I think maybe you just don't need sequence generator in your, like, either you do like sequence generator self sequence generator, or you just skip the first part, if that makes sense.
On the line that it was giving me the error, you mean? On 44?
Yeah, you imported the namespace sequence generator already, right? Through this thing. So I think if you re-reference it again, you don't
through
need
this,
it.
you mean? Oh,
Yeah.
I see. Okay. Let me see if I understood what you're saying. So instead of having to say, oh, well, here's another part of the problem.
Yeah.
I spelled that wrong. Maybe that's it. But Sean, if I understood what you were saying, maybe like we possibly didn't need that part of it.
You didn't need just not everything highlighted, but just the sequence underscore generator. But yeah, I think you should try it with just the typo.
The typo was certainly wrong. Yeah. Okay. So, same line. Use of undeclared type or module. Okay.
Yeah,
so
now I just remove just that part.
This is what you were saying?
Not the whole thing, just the sequence generator part.
Oh.
Because you see, you already imported sequence generator, the capital one, under the namespace.
Okay, understood. I think this is what you were saying, right?
Yes.
Okay. Sequence generator not found in trait. That happened earlier.
Did you add it to this trait?
Yeah.
Sorry, go up. You called it.
I called it seekgen. Yeah.
Yeah. So you put seekgen there.
Yeah. Okay, this is looking pretty.
Yeah. Actually, one thing I suggest is, I don't know for clarity purposes, but to import the sequence generator using the crate name. So the way you had it before was kind of better, because then when you switch it, it'll be more illustrative. But
you're talking about up here?
Yeah, so instead of using use crate, get rid of that sequence gender part and add back in
and
the other
switch
thing.
the last line back. Yeah.
Yeah, and then you'll really see that you can switch the two crates kind of on the fly, right?
Yeah, that's a great point. Where was that line?
Yeah. And so for everyone else watching, I mean, basically it's just namespacing stuff. Nothing here is changing any logic.
Nice. Okay. Let's see if we can come. Oh wait, I didn't fix this.
Account ID, yeah.
Before.
So maybe just pass the ID into next state selected, and you just basically get an event of who called.
Oh yeah, who did it?
Yeah, it doesn't matter. Just get rid of the error. Because if you get rid of account ID, then you have to get rid of the T, and you get rid of T, then it gets all this other problems. I would just add the account ID there.
What if, here's just my question.
Mm-hmm.
What if can we omit this?
I think then it will say that there's no T being defined in event T, and so you have to remove the T as well. And if you remove the T here,
then you're saying I have to go all the way back to here.
And then remove the T here. Okay. And also you have to remove the T in the deposit event definition.
Oh,
you can go down this path. I don't recommend it right now.
And just for completeness, the deposit event is
Oh, you need to define it.
Oh, I deleted it. Yeah, I actually need to put that back.
Yeah. So we function deposit event.
Yeah. Oh, nice.
Deposit event. But you have to put a T before the parentheses. Yeah, parentheses equals default.
Okay, cool. Nice. And okay, yeah, so we'll just do.
And you have to uncomment the stuff you commented out.
Yeah. And I need to call that thing with like that.
Yep.
All right. Whoops.
Oh yeah. One last thing.
Okay.
Looking good?
Yeah. Great. Let's try to run it. I think I purged my chain, but you can never be too sure. Oh, hey, by the way, I'm trying a new mic today. Anyone who's been on the call before, does it sound any different or better or worse or anything?
It sounds windy earlier, but now it sounds clear.
Okay. All right, nice. So, well, I guess while we're waiting for it to load, it's maybe always best to state expectations. So now that we have both of the runtimes in here, I'm expecting I can call the dispatchable part from either one of them. Ooh, I can't. Okay, and I think that's because I tried to take the shortcut of...
Just maybe refresh?
Well, I didn't build the... I will refresh, but I didn't build the native that time, hoping that...
Oh, you have to. You have to.
Yeah.
Or I thought you have to do a runtime upgrade.
Yeah, see, oh, you have to do a runtime upgrade? Okay, yeah. I really am looking for ways to make this process faster, especially for times like this when, you know, everybody's kind of like hanging out together, working on it together. It would be nice to get quicker turnaround.
In general, probably what's going to happen is there's going to be a refactor soon. Not soon, but at some point, which just basically uncouples some of the dependencies. So as people work on the code base, you know, there's more and more like crates get imported for no reason, all that kind of stuff. And then often there's kind of like a purge where you like refactor all the crates so that more crates live independent of each other. And then you don't have things like this where building one crate takes really long because it maybe has a bunch of other dependencies it has to build as well.
Yeah, I didn't even think about the problem that way. That makes a lot of sense.
But I mean, in general, I don't think Substrate is built to have that like JavaScript feel of like just run and gun type thing. I mean,
Yeah.
runtime upgrades really is one way to do it, but you can only do some kinds of changes to your runtime using runtime upgrades, right?
Yeah. It might be worth exploring that path just to kind of like as a learning exercise to see where the limitations are, and also just to get like, when you go through a process 5 or 10 times, you really start to understand it and remember it. Like we'd all be experts at runtime upgrades.
Yeah. I mean, I can tell you where the limitations between runtime upgrades is your logic has to always understand the current state of your blockchain. So if you do anything that like fundamentally changes, like, oh, this is U32, now it's U64, you basically have to purge a chain, or you have to write migration logic for that change.
Okay, that makes sense.
Runtime upgrades can.
Here. So like, so right now my integers thing only has one storage item, and it's typed in U32. So if I just like added another storage item in there with some type, that probably would be runtime upgradable, because the one that was there still works exactly the same as it used to work.
Yeah, exactly. So new storage items work just fine.
Okay.
I think
changed or removed though probably would be trouble.
No, you can remove items. They won't be like officially removed from your chain storage, but you can just like have functions not reference them anymore, right? Or not expose it in your metadata. What happens really is when you do modification is the problem, where your logic expects one state, but then your chain has another state, and unless you've explicitly written that migration logic, you get to issues there.
Yeah, okay. So I think I get it now. So you're saying like if I remove something from storage, then of course I also had to remove whatever like logic was touching that storage, or else it wouldn't even have compiled. So removals are also okay because they mandate like that the code that used them also be changed.
Exactly.
Okay, cool. That makes sense.
And again, do you have to remember that Substrate is just one giant key value database, right? So when you remove an item from your module, you haven't changed the state of your chain. If you went to the same key value store, you would get the same. If you went to the same key, you would get the same value, right? And the key is just like some encoded hash thing. So
the key value thing
removing doesn't do anything.
That's what we usually think of as like the state tree, right? That's the same thing you're talking about.
Yeah. So in this case, it's one key value storage, and then the key for any module is like the module name plus the storage name plus something else, then hashed, and that is the unique key for that storage item.
Yeah.
But you can see how removing the storage item doesn't affect anything, because even though the storage is still there, it's just not being used anywhere.
Yeah. Okay. So Sean, you're saying like we can kind of get away with acting like there's all these different little key value pairs where we're acting like there's kind of one per module, but the substrate behind the background or in the background there, it's kind of just giving them more like fully qualified names behind the scenes, so that the storage that I'm thinking of as like current integer or whatever is actually like my module's name concatenated with an instance concatenated with what I thought it was originally, next integer, and then that's like the real key.
Yeah, that's exactly right. There is not one database for each module. There's one database for Substrate, and using this like key hashing, we are able to take that one database and of course, uniquely divide it into the sections for each module and avoid collisions and stuff like that.
Yeah, cool. Okay, so we're a few minutes over, so I'm going to run this one last time, and then we'll call it. And I'll also post this on my GitHub, and we can leave it as homework to go through and do the second implementation of our trait. Release state change. I don't remember if I purged. Oh, let's see, so there's a question in the chat. Forking the chain, right? Should we think about it as two versions of the chain running? Can one run multiple versions of a chain? Yeah, I mean...
So yeah, forking. I think forking is something that's kind of like a term that's a little bit overused. Like for example, forking describes both like some kind of consensus problem, or describes like a planned upgrade, or to define some kind of like like one disagreement with one group with another, so all that kind of stuff, right? In general, yes, that if there are two versions of a chain with different logic, and those two logic cannot come to consensus with one another, you have created a possibility of a fork, right? So one person's node creates one state, and the person's node creates another state. They don't agree on the state, and therefore they can never come to consensus with one another. When you do a runtime upgrade, we do this what we call like forkless upgrades. Basically, because the runtime lives on the chain as a WASM, we can ensure that anyone running a node and is in consensus with your chain during the upgrade will get the latest WASM and always use the latest runtime for producing blocks and validating blocks with that. So you shouldn't think of it as like forks, but you should think of it as like upgrades.
Yeah, the framework in my head for that kind of stuff is that basically a fork happens whenever there's a consensus change. And then, like Sean said, there's a lot of reasons that could happen. You know, sometimes it's because, you know, sometimes it's like the ETH Classic or the Bitcoin Cash fork where people really did have different opinions. Other times it's because like someone forgot to upgrade their node or something like that. And so the reason that these like upgrades without having to pause the chain or, you know, coordinate everybody doing it at the same time is nice is because it prevents that accidental fork, you know, where like it wasn't contentious, just some people didn't update their nodes or something like that. And so then we don't have to accidentally fork.
So there will not be two runtimes running. At any point, only one runtime will be running. So there will be a native runtime and a WASM runtime, and there's logic in your node so that it picks the one which matches what is on the blockchain. It matches the consensus of the rest of the network. So if your native runtime is exactly the same version as the WASM, it'll run the native, which is faster. But if it doesn't match, it'll always use the WASM. So there's always the WASM as the fallback. I'll send you I'm gonna put a Stack Overflow post.
Cool. All right, guys, so my expectations were violated. We don't have the wrapper showing up here still. And my hypothesis, I think I just remembered that we might have accidentally named both modules integers because I created the wrapper by copying integers.
Did you import it into your construct runtime?
Here, yeah, I did.
Then it should be, yeah.
Yeah, and they both have call there. Okay, so that's okay. This is one of those weeks where we're going to end with a little bit of a mystery, a little bit of a debug, and I'll push this code as it is right now to my GitHub, and then if anybody wants to take a look, you can, and then in a little while, maybe later today, I'll push whatever the fix was for why we couldn't get wrappers to show up. And and also I'll say sometimes the problem is like not a legitimate code problem, but like I was doing something silly like forgetting part of the recompile process or something. So in any case, look forward to all figuring that out together. So thanks everybody for coming. Any last questions or comments or anything you want to talk about before we head out?
No, it was good. Thanks.
Oh, I see, Sean, you said you want to pick up from here next week. Yeah, let's see. Everybody can voice their interest on that. Thanks, everybody.
I'm down.
All right,
take care.
Thanks. Later. Bye.